types of operating system, we will see processors, single processor and multiprocessor operating system. Now basically a single processor operating system is a unicore model. I am talking about the classic unicore model. Now we are getting multi-core models and quad-core models available. The unicore model, where we will have only one processor chip on the motherboard which will be executing our program instructions. Basically the idea is a processor at any given instance or any given processor cycle will execute only one instruction at a time, and in the next cycle it will take up the next instruction. The single processing model are conventionally are much more stable, but the problem is the performance. There is no parallelism, the performance is very low. Next is a multiprocessor model. You must have heard about dual core, quad cores, core to duo systems, multi-core systems as such. These multi-core systems are basically one chip having multiple cores. Here a server system basically is a multiprocessor model. Now what do you mean by multiprocessor model is, I have more than one physically separate chips in a motherboard. So there are multiple processors in one system, and parallelly all the processors can execute different instructions. So that actually significantly takes up the performance, and compared to a single processing model, multiprocessor models are much more faster. Next we will talk about different types of jobs. In jobs basically we have multitasking, we have multi-programming systems, we have time sharing, multi-threading, batch systems which were classic batch systems, real-time systems, network-based systems, and dashboards, distributed systems. The next, when we started with the operating system as such, we basically started with batch processing system. It was basically uniprocessor model, so only one process at a time was taken up. To make it more precise and efficient, we started with batch processing system. Now what a batch processing system does is, it collects these jobs in series and converts it into a set of batches. Each batch is submitted, and till one batch is finished, the next batch is not submitted. One batch consists of n processes, and there can be m batches in this manner. So batch processing system is a very simple scheduling system which actually schedules this process one after the another. And basically more than the conventional model, this is performance, the batch processing system performance is better. There are two varieties of batch processing system. One is a stacked system, and other is a spooling system. Now a stacked system or stacked job systems is basically doing only one thing. It stacks up all the processes or batches one behind the other till one batch has finished its work. The other batch cannot take up. So the output of a particular batch will be only given only after all the process in that respective batch is finished, not intermediate. On the contrary, spooling systems, now spool basically stands for simultaneous peripheral processing online. A spool basically consists of set of processes in one batch, but the speciality of a spool is that we can in spooling basically after completion of intermediate job also we can retrieve the output. Unlike the stacked processes, the performance in stacked processes is much more higher than the spooling process. So performance wise spooling process falls short because intermediately the operator has to extract the outputs of these processes which are in a given batch. This was basically